Hi everyone, today we're going to talk about solving rational equations. A little bit different than solving other types of equations, simply because with rational equations we have a variable in the denominator. So the only reason it's different is really just the first step is working to get rid of that denominator. And then it's just like solving any other equation. Okay, so what we're always going to do when we are solving an equation like this is that we are going to look at the denominator and figure out what the least common multiple would be of all of our denominators. And then we're going to multiply by that to get rid of all of our denominators. Let me show you what I mean. In this case, my only denominator here is x. So I'm going to multiply every single term of my equation by x. Okay, so I'm going to multiply this by x. I'm going to multiply this by x. And I'm going to multiply this by x. I multiply every single term by x. Now, here's what happens. Here, I have two x's in the numerator. So I have x times x gives me x squared. Here I have an x in the numerator and an x in the denominator, so those are going to cancel each other out. So now I have x squared minus 18 is equal to 3 times x. So notice I went from this sort of complicated looking equation to one that's very straightforward and easy and something that you've seen before, right? This is just a quadratic equation. And now, very easy to solve it, we just get all the terms on one side. So if we subtract 3x from both sides, we end up with x squared minus 3x minus 18 is equal to 0. And then in this case, we're going to have to factor. So I need two numbers that add to negative 3 and multiply to negative 16. So I have x equals negative 6, or excuse me, x minus 6 and x plus 3. And then when I set each of those factors equal to 0, I get x equals 6. And I get x equals negative 3. Now, a lot of people would stop here and they say, okay, I found x, I'm all done. It could be 6 or negative 3. Here's the one really, really, really important thing that you have to do whenever you're solving a rational equation. And it's very easy. All you have to do is check these back in the original function. You basically have to check to make sure that they don't make the denominator 0. If either of your answers, if any of your answers ever make a denominator 0, you have to reject it because you can't divide by 0. So I can use 6 or negative 3. Neither one of them make that denominator 0. So those are both going to be my solutions. Okay. Let's try another example. This one, there's more than just one denominator, right? In that other one, we only had x in the denominator, but this time we have a 3 in the denominator and we have an x in the denominator. And so now you say, all right, well, what am I going to need to do? I've got this and I have this. So my least common denominator, my least common multiple of those would be 3x, 3 times x, right? There's nothing common between them, so if I just multiply them together, that gets me that common denominator. Okay, so I'm going to multiply each term by that common denominator. So I'm going to multiply this term by 3x. I'm going to multiply this term by 3x. And I'm going to multiply this term by 3x. Every single term in the equation is multiplied by that common denominator. Now watch. Here I have a 3 in the numerator and a 3 in the denominator, so the 3's will cancel, but I still have x times 10, which leaves me with 10x. Here I have an x in the numerator and an x in the denominator, so those will cancel, but I still have 4 times 3. That gives me 12. And here I don't have a denominator, so there's nothing to cancel. You only cancel when you have something in the numerator and something in the denominator. So that would just be 6x. Now this is a very, very easy equation to solve, right? Subtract 6x from both sides. You end up with 4x is 12, and x comes out to be 3. Make sure you check back in the original. It does not make that denominator 0. So we're good, and that is our answer. Okay, so it is very straightforward to do. It's just some of the problems are a little bit more complicated than others. In this next one, we have 6 over x plus 5 over 4 equals negative 7 over 4. 6 over x. Hopefully you guys are writing all these down so that you have them to refer back to when you're doing your assignment. Okay? Again, I'm going to go ahead and I'm going to circle my denominators just so I know what I'm working with here. Now, 4 is common to both of these, but none of them have x. So my common denominator is going to be 4x. If by chance you say, well, if I just multiply them all together, I end up with 16x, and I'm going to use that, there's nothing wrong with that. You can also do it that way. It's just larger larger computations you have to do. Okay? But it's not wrong to do it that way. But I'm going to stick with 4x here. So I'm going to multiply this by 4x, multiply this by 4x, and I'm going to multiply this by 4x. So here my x's eliminate, so I'm left with 24. Here I can cancel out my 4's, so I'm left with 5x. Here I can also cancel out my 4's, and I'm left with negative 7x. Okay, I would just from here move the 5x. So I end up with 24 is equal to negative 12x. Divide by negative 12, and you end up with x is equal to negative 2, which does not make your denominator 0, so that's okay. Sometimes our equations have more than one term in a single denominator. So for example, these have binomials in your denominator. You are going to treat this, though, as a single term. So if you notice here, right, this is 1 and this is 1, but they're the same in both. So my common denominator here is just x minus 2. So I'm going to multiply this by x minus 2, and I'm going to multiply this by x minus 2. Because I have an x minus 2 in the numerator and in the denominator, I can cancel those. So on this side, I'm left with 5x. On the right, I have an x minus 2 in the numerator and the denominator, so I can cancel those. Here I have 3x plus 4. And so now I'm going to solve this. So if I subtract 3x from both sides, I get 2x is 4. And so I get x is 2. Now, if you're not careful and you don't check, you're going to say, well, that's my answer. But look what happens when you plug it into the denominator. It makes the denominator 0. Because it makes the denominator 0, it cannot be a solution. And since there aren't any other possible solutions, my answer here is no solution. Okay, that's my answer. You can also write that as a 0 with a line through it, like a diagonal line through it. That means the null set or the empty set, meaning there's nothing that satisfies that problem. So they mean the same thing. You don't have to write both of them. You can just write either one of those. Let's do another one that's similar to that. This one's just a little bit harder, but again, just think about what it is you're doing, right? If this is one denominator, here's another denominator, and here's another denominator. So two of them have x minus 8 in them, and only one of them has 2. So my common denominator here is 2 times x minus 8. Right? It appears more than once, but I only need it once as far as the common denominator goes. I'm going to multiply every single term by 2 times x minus 8. Again, here I'm going to start canceling. So I have an x minus 8 in the numerator and in the denominator, so those will cancel. I'm left with 2 times 2x minus 5. In the second term, I have a 2 in the numerator and a 2 in the denominator, so I'm left with x times x minus 8. Here I have an x minus 8 and an x minus 8, so I'll cancel those, and I have 11 times 2, which is 22. When I distribute, I end up with 4x minus 10 plus x squared minus 8x is equal to 22. So I have a quadratic, which means I'm going to want to get everything over on one side of my equal sign, which means I'm going to first combine my like terms. So I have x squared, 4x, and negative 8x is negative 4x. If I subtract 22 from both sides, I end up with negative 32 equals 0. And so now I'm going to factor. Two numbers that add to negative 4 and multiply to negative 32 would be x minus 8 and x plus 4. Solve both of those. Here I end up with x equals 8. Here I end up with x equals negative 4. Check them back in your original problem and see if either of them make the denominator 0. X equals 8 would make that denominator 0, so that can't be one of my answers. I have to reject it. And my only answer here is negative 4. One more problem. This is just, it's not hard, it just has a little bit more to it. In this case, I have two denominators that are completely different. However, this denominator I can factor. Okay, so you might be in a position where the first thing you want to do is factor to see what you have in your denominators. So now I can say, all right, well, they both have x minus 4. But only one of them has x plus 4, so my common denominator is going to be x minus 4, x plus 4. X minus 4, x plus 4, x minus 4, x plus 4. Here the whole thing cancels, so I have nothing left there. And here the x minus 4's cancel. So I'm left with 16 is equal to 2 times x plus 4. And when I solve that, I distribute. Subtract the 8, I end up with 2x equals 8, and so x comes out to be 4. 4 makes my denominator 0, so I have to reject it. And the answer then would be no solution. Okay, so the reason that you're doing what you're doing in every single one of these problems, the reason you're multiplying by that common denominator is to get rid of the denominator so you can just solve it like a regular equation. Okay, like I said, it's not hard. It just requires a few more steps to solve for your missing variable. Hopefully that helps. We'll see you next time, everybody. Thanks.